Today we're on the lower half of page 8 of the Chapter 14 AP Chemistry packet. We're going to be discussing salts and how salts can react with water to produce either acidic or basic solutions or possibly a neutral solution. And a vocabulary word you might want to know for this is hydrolysis. Hydrolysis means reaction with water. So hydrolysis is a reaction with water. So what you want to do is you want to take a look at the formula of the salt, understand that the salt does dissociate into two parts, the anion and the cation. So this is soluble because of group 1 and Brickle-Strickle. So there's a K plus and a Cl minus. Then what I like to do is I would like to write HOH underneath it. This is just a quick shortcut to figure out if the salt is going to react with water at all. And then it'll help you to write the equation if there is a reaction. So let's first start with the KOH. KOH, is that a strong base? It is because it's part of LICA. So remember, strong acids and bases do not want to go together. The K plus is not going to want to grab an OH minus from water. So it's just going to leave it alone because it would form a strong, and strongs want to be apart. Then look at HCl. Same thing. Strong acid, it's part of Hickel, Hibber-High, etc. So therefore, it's not going to take the Cl. I'm sorry, the H. The Cl will not take the H. So nothing's going to happen. So this solution would be a neutral solution, and there will be no reaction at all. Okay, now we're going to take the NaF. So NaF also can break apart, and let's write HOH over here. And so we're going to again consider each part. Let's try the H and F. Okay, that forms an acid which is not a strong acid, it's a weak acid. So therefore F minus does want to grab the H plus, whereas NaOH is strong, so therefore the OH and the Na will not go together. So now what you realize is that the F minus is going to take the H from water to form HF, and this helps you to write the net ionic equation. So let's do that. We're going to write F minus AQ plus water. I'd like to write HOH, but you don't have to. And you're going to see that the H is going to go with the F to make HF. And that will leave behind the hydroxide from water, AQ. And there's going to be your net ionic equation. Now you'll notice that I left off the Na pluses. You could actually write them in. Na plus is going to be in the beginning, and the Na plus is going to be at the end. It's not going to go with anything because it doesn't make any solids or precipitates. So therefore, remember what we call this. It's called a spectator ion. So you could just cross it off. And these are called spectator ions. Spectator ions. Because they just watch the reaction happen and they are not involved. Okay, so this solution you know is going to be basic because the OH was formed and made the solution basic. Okay, let's look at the next one. Let's write an HOH down here. And we're going to look at these charges. Again, this is going to break apart because of nitroclo acetate. So look at the CaOH. That is going to form a strong base, so it does not want to go together. But this is going to form a weak acid, acetic acid. So that will want to take the H. The acetate will want to take the H from the water. So that's going to leave behind, again, like the other one, it's going to leave behind the OH minus. So this is going to make the solution basic. And how do we write this? So we take the acetate, C2H3O2 minus. We're going to react that with water, which I personally like to write HOH. Then you could form the acetic acid because the acetate wanted to grab the H from the water, and leaving behind hydroxide, which again makes the solution basic. This is aqueous, liquid, and aqueous. Again, the spectator ion would have been the calcium. Now, when you look at NH4Cl and you first realize that this breaks up, the first thing you need to realize is, or ask yourself, is this already an acid? Okay, so before you even do HOH, look at NH4 plus. This is already an acid. If you see something with like H that it can give up, like an ammonium, it's going to be an acid. So you don't even need to do HOH for this. All you do is write the ammonium giving up an H. So ammonium giving up an H is going to be NH4 plus AQ. Now you could just break it up like this and write H plus and AQ and ammonia AQ. If you prefer, you could react it with water and make the water take the H. So you could write NH4 plus AQ plus water. This time I'll write H2O liquid. We'll make H3O plus because the water grabs the H to make the hydronium ion, don't forget. And then you're going to have your ammonia NH3. Either way you want to write this is fine. They're both acceptable ways to write it. Okay, so this was acidic. And then lastly, we're going to look at NaHSO4. Again, this is going to break up into Na plus and HSO4 minus. First, check to see if there are any like H pluses that can be given off. And again, you see that HSO4 does have an H to give off. This is the bisulfite ion. So this is going to be AQ. It can give up an H to make H plus and SO4 minus 2. And if you prefer to write that with water, then you could write HSO4 minus plus water yields H3O plus and sulfate. Either way you want to write this is fine. And that would make the solution acidic. So real quick, 30-second recap. Whenever you want to see if a salt reacts with water, which is called hydrolysis, you see what the salt, what ions into which it splits. You see if it forms any weak things that want to go together, leaving behind the other part of the water. Before you even do that, you want to also look for if there are H pluses in one of the ions, and if there are, then automatically that's going to make it an acidic solution, and you don't even really need to do the HOH for those.